let's then change and turn our attention to the whole notion of really the last two steps, all those coordination steps that your BIM coordinator is going to lead for your group, because after all the individual designers do their specific pieces, that person's going to pull it all together and kind of like get people going. So let's talk about how this can work. So the idea is that we've created a bunch of separate models. We have the architectural model, maybe the structural model separate, it could be in the same file. The mechanical model, the HVAC model, they're all separate or together, but we're going to pull them all together. We're going to pull them all together with this tool called Navisworks, which is really, again, it's my Swiss Army knife. It pulls anything in and lets us kind of coordinate things. Navisworks is a very useful tool because it'll let you get file formats from very different products. If someone's creating something in Tekla, or someone's creating something in ArchiCAD, or just in CATIA, or any of these other formats, Navisworks allows you to pull them all together, okay, and coordinate them. It's interesting, Navisworks doesn't let you change the underlying models. Okay, the models that were actually used to create the design still, we can look, we can see, we coordinate, but we can't change. When it comes time to change, we have to go back to the original design model, and that's by design. Because I don't want to give you my structural model and have you have the ability to change it on me. I'd really rather that you tell me I need to make a change so that I can control that and give it back to you. And this whole notion of working with files and doing it that way, this is one way of doing it. There's another way of doing it that involves doing it on the web in real time in the cloud, and we'll play around with that next quarter too. But it's there's a file-based version, there is more of a web-based version. And someone asked this morning, it's kind of a really good question, who typically actually does the BIM coordination? I should ask you guys, because I think most of you guys do know. Like, who typically does the BIM coordination? I think you construction guys will know. What's that? Actually, that's a very interesting thing. You would think architects would want to do that coordination, but they rarely are the ones who do it. It's almost always the constructor. It's always the whoever. There's always going to be someone who's coordinating, and since ultimately that general contractor typically has responsibility for building it, often they take the lead in this. It's really, really odd. You think the designers would want to take the lead, but they often don't. It often goes to the general contractor. So it'll be their meeting in their trailer where they get everything together. But that's why it's very important for design to get contractors involved, to be involved early in the design process. As part of a whole integrated design process as opposed to just bidding on things after they've already been designed. It really helps the process. Okay, let me open up Navisworks and we'll take a look at how we're going to approach this. So Navisworks is, again, another application, Navisworks Manage. Let me open that up. And we'll bring some model files together. I think I'm opening that up. Now Navisworks is such a fantastic general purpose tool. The biggest problem I tend to have with it is there's a lot of windows that are flying in all over the place. It's just kind of hard to keep track of everything on the screen at the same time. So let me even close this one that I left open before. Kind of open just sort of this kind of very big blank window. It's just waiting for us to load things into it. Okay, and in this big blank window, we're going to start by just opening or appending files. If I have an existing Navisworks file I've saved, I can open that. I'm going to append and we'll save a file. And what I'll do is I'll just choose append, and I go out and choose the models that I want to bring together. I'm going to go out to my session 18 folder. And again, all these things are hanging around out there. Let me kind of say all file formats they're really Revit files. Watch out for that. You have to kind of change the file formats. Let me get that architectural model. I'll bring it on in. There it is. Not looking too bad. Okay. Now, there's actually a tree that shows all the things that are modeled. I can open the little selection tree. You might have to click this button to kind of bring it open in the first place, but there's the architectural model. And you can see that in this model tree, I can choose the entire model, or I can choose a specific level of the model, or I can even expand down and sort of just say only get the walls on the third floor. There's a whole hierarchy to how it organizes information, but all the information from your Revit model and all of the elements is here. And you can kind of access it and query it, and we can figure out what intersects and what doesn't intersect. So I get the curtain panels, the curtain wall mullions, whatever it is, on an individual floor or a whole floor at the time. Yeah?
the groups are already set up from Revit, or you have to create the groups?
These groups here?
Yeah.
These groups this is sort of a default format based on what Navisworks does in the Revit data structure. We're going to talk in a little while about how we can actually use project parameters to create our own groups. But by default, it brings them in this way. And actually, you're on to sort of the heart of the issue, which is where one of my struggles with Navisworks is, I don't think about things the same way it does, so I often play around trying to find things in here and struggle a little bit. So we're going to talk about how to create a scheme that gives us more control over that. Okay, so it comes up with its own level. It's a notion of groups. Okay, let me append on in the structural model. Okay, you won't see very much right now. It is in there. I can tell, well, I can see a little bit of the cave racing right here, and actually the foundations are here too. So I know it's in there. Now, I didn't have to do any translation. These models had the same origin system. If I needed to translate the model, I could. I can say, for the structural model, if I right-click on that, well, I can do some sort of transformation where I can move it around in X, Y, or Z if necessary to get everything to line up. Okay, but I don't need to. Let me go ahead and I'm going to bring in that third model. Append in the MEP model. And it is here too. Again, you don't see it all. But we can go ahead and make these things more visible. Let me go ahead and pin this for a second so I can see it. And what I can do is, for example, if I want to hide the architectural model, I can right-click on it and say hide it. Okay, it'll strip it away so I can actually see things a little bit better. It's still there, it's just hidden from us. I can see a little bit about, oh, there's that MEP work there up on that side. So in this model over here, oh, I can also just choose things in the window. There's a ceiling plane right there. Maybe I want to hide that. In fact, if I choose something in the window, notice it actually shows me where it lives. That's part of the MEP model. It's a compound ceiling right there. So I can hide that one away if that's going to make it easier for me to see things right now. I can even come in here. I'm not sure what this element is at the top. See there, well, I can tell you now, it's a floor. It's a floor of the roof, basically. Let's see if I can hide that. Okay. So now you can sort of see a little bit better what's going on. Let me orbit this around a little bit more. You, over there. And if I go zooming on in here, you might be able to see some different issues that are hanging around. Actually, this doesn't look like it's doing too bad, which actually sort of surprises me. I wonder if I actually saved my MEP model last time, because it's looking a little lower than I'm used to. Well, we'll see what's going on. This one I might have actually fixed my problems already. We'll figure out how it's going to go. Okay, so you can sort of hide things. Let me just kind of take a look at something. No, it's over there. Oh, you know what I need to do? I'm going to bring in a different MEP model. I sort of fixed my problems in the morning session, so I don't have nearly as many problems as I should. Yeah, which sounds like not a fair thing to do. But let me go ahead and I'm going to delete this model. I'm going to bring in the other one that still has the problems. Otherwise, it's not going to be nearly as fun. So I'm going to go back to session 17, where I think I have it over there. Ah, this one has more problems. That's what I was looking for. So in this version here, you can start to see, yeah, I got some issues. There's some stuff going on here where there's, ductwork, there's piping. I got some things that are conflicting here. Because, again, what happened, it's not like anyone did anything bad. We just all optimized for our own purposes without being aware of each other. And now we have some conflicts. Okay, so after you've merged all your models together, a very good thing is to actually save this model set, save this file set, so that you don't have to keep on doing it again and again. So what I tend to do is I'll go to the application menu and do a save as, and I have a couple choices here. We talked about these last time. The Navisworks file set sort of links me to all these models in a live way. So if anything changes to the architectural model or the mechanical model, the newest version is always going to be there. It's fresh, it's alive, it's kind of constantly updating. And that's kind of a cool way to do it as I'm working. So I'm going to say, save it as a Navisworks file set. I'm going to put it back into session 18. And I'll say coordination night version. Okay, save that away. The nice thing about this set is it's always going to be dynamic, things like that. The bad thing about this set is I need access to the files. So if somehow this file and the underlying files get separated, you may need to link them back in again. It's in the needs, they're still hanging out loose. Okay. So the other way you can save this is save it as something called the Navisworks document. The Navisworks document is useful from the standpoint of that actually copies everything in, so I get a completely self-contained file. I can give you one file and it'll have everything you need in it as of 6:05 p.m. on 11/21. Okay, it's locked in time to right now. Yeah. Good for that. It's nice to have a snapshot of what's going on. It won't update itself automatically. So easy, give you a snapshot. A little more complicated, give you a live linking thing that's more useful. Okay, so generally, as you're working, you tend to create a file set because what you want to do is continue to kind of keep that set open as different people update the files. You can sort of see what the impact is and change things. So better to go ahead and have a set, typically. But when you want to give something to someone where you give them a self-contained one file thing that they can't change, give them a document. Okay, so I'll say and then I'm going to go ahead and open up that file version because I think I just saved it as a document. The file set. Okay, so these elements are live now. So we can go bopping around and look at things, and I can spot different things that don't look so good and kind of figure out what's going on. You know, just stumbling through finding things, and visually, you know, your eyes are pretty good at detecting these things. Something doesn't look quite right about what's going on here. If you want to go through and use the clash detective, the clash detective is really just an automated tool to help you find these things. So all it does is really say, hey, you've got some sort of XYZ space you're trying to occupy. I've got an XYZ space. If they're overlapping, I'm going to put it on a list of like issues that need to be solved. So it's sort of a more systematic way of approaching it. So how that works is there's something called the Clash Detective tool. And if you open the Clash Detective tool, it looks like this. Okay. You define different tests which are things you want to compare to each other. Okay. So at a really high level, I could define tests that just compare the entire structural model to the entire mechanical model. I think I showed you that last time. Let's add a test to this thing. I'm going to go through and just put in there, what I'm going to do. This is going to be entire structure versus mechanical. Okay, that's a test. Nothing's been defined for it yet. I'm going to say, what do I want to have happen, to be tested in that test? And I can choose that, I'll get the entire structural versus the entire mechanical over there. Okay. And that's kind of a relatively gross test. It's just sort of going to capture a lot of things. It'll capture what I'm interested in. It'll probably actually capture a lot of false positives too, because I'm just sort of sloppy about my modeling. Every time something pokes through the ceiling, I don't necessarily put a cutout through there. So there's a lot of things that it'll catch, which are probably okay in the scheme of things. Let me say run that test. Okay, found 109 things that it thinks are somewhat questionable, at least overlap with each other. Let's take a look at those. You can, for example, choose this clash. And this clash, I can tell, is basically some sort of structural columns conflicting with an acoustical ceiling tile. Okay, that's an example of, I'd probably put that in the false positive category, in that that's not as interesting to me as a piece of framing conflicting with a piece of ductwork. Okay, so for this, I can say that, this clash is, well, I'm just going to approve this. This is kind of okay. I'm going to let it be individually. I can go to the next one, see what's going on, sort of a similar thing. I'll approve that one too. What's happening is, as I'm doing this, I'm moving clashes from new to approved. So hopefully, we're kind of dropping them down there. We're sort of closing out issues. We're going to try and get that number as close to 0 as possible. Okay. Another way you might approach this is, you can, for example, say, this is all the ceiling over here. Really, anything that has to do with the ceiling or just these ceilings, I'm just not really interested in those things. So I could basically group the clashes that involve the level 3 ceilings, because as a class, I just want to knock them all out. I'm just really not interested in anything involving a ceiling. So if I choose that, I can say group it. See if that actually worked. It might actually have to be that I go through, and I can't do it for the group. I have to do the individual item. Try it down here. Try grouping that. I'm looking for my group. I'm not seeing it. Are you top? Are you bottom? I want it to be that one. Find all clashes involving this item and combine them into a group. Maybe there's only one. Intriguing. Let me go for another one. Again, I got that compound ceiling. Nope, my grouping's not going to work today, just to kind of bother me. Well, we'll leave that at that for now. In terms of actually finding them, I could also go through and just choose a bunch of them and group them and say new group there. It's just another way of doing it. But I'll leave that alone for right now. Not sure why that's not working for me right now. The other thing you may want to do, though, is actually be a little bit more careful about defining your clash tests. So as opposed to saying entire structural versus mechanical, the truth is I'm pretty much only interested in beams and framing elements versus ductwork. That's what I'm really kind of after. So I could add another test. I'll give it a name. So I'll say structural framing versus ducts. Okay, again, just different name. Nothing special about that. For structural framing versus ducts, I can now be a little more careful about what I'm doing. So for example, if I want to choose the structural framing, and I'll choose the structural framing on the roof level, maybe the structural framing on level 3, you can decide really how fine or not so fine you want that to be. Hang on. I keep on hitting the control command as opposed to control. Okay. So I get the structural framing on a couple different floors. Now, this is that whole thing about, I have trouble sometimes finding where things are, because the framing for the roof is actually considered to belong to the roof, not to level 3. There's kind of this issue about where it's going to live in the hierarchy. And I can compare that to, for example, on the MEP model, what do I have at level 3? I have some ducts and duct fittings on level 3. So I'm going to grab those. So this is really, what would I call it? This is a more refined test. It doesn't include everything. It'll give me hopefully a much smaller result. So I could say run that test. Okay, you see, because there's only 51 elements there. And the good news about these 51 elements is these are, well, probably a little more or closer to what I really care about. If I go through and choose one of these clashes, you'll see, oh, there's some sort of piece of, that's a brace coming up. Scroll on down here. There we have, oh, pretty squarely, we have some W14 by 30 running into a piece of rectangular duct over there. Okay, so this is where we want you to get to first, is really just run some clash that has some initial results. Okay, and right off the top, okay, 51 problems here. Okay, before you go ahead and start correcting something, stop, pause, make a report of this, because this is really your baseline if you're going to be improving from. You may not get down to 0, but we know you're going to get better than 51. Okay, so what we need to do is you can switch over to the reporting tab. You can decide what sort of things you want to report, whether you want to report which pieces of information and which statuses. Like, I'm not going to include the ones that are approved or resolved, because those are, as far as I'm concerned, done with right now. I'm just going to get the things that are sort of active or in process. I can really group this a lot of different ways. I can sort of group it by like who things are assigned to. You can be quite precise because you don't want a list of all 51 classes. You want the 20 classes that are assigned to you, and you want the 10 classes that are assigned to you, and you want the 5 classes that are assigned to you. Okay, but we'll create the big report now. You have different formats for reporting it. I'm going to put it in HTML, so I can write that report. Save that away. It'll make a nice little HTML report that'll have pictures in it and text in it, things like that. And if you run that report, if you open that report, it's HTML, it'll open your web browser. So in Chrome or in Microsoft Explorer, whatever you want, or Windows, yeah. So where is that? It's hanging around out here. There's the folder. There's the actual Google file right there. Let's open this up. There we go. So within this, there's all these different clashes. So here we have some, those are the braces. Those aren't so interesting to me. I'm going to go through and approve those in a little while, because they're just intersecting with the ceiling. Now we have, the better clashes. This is actually, what is it, some W21 by 55 is conflicting with a rectangular duct. That's interesting to me. I know it's on level 3. It's at about level D2. I have a specific point where it's clashing. I know how much it clashes, about 1/3 of a meter. Okay, so that's pretty big in terms of the overlap. So we have all these, and this is a nice hit list. So in a lot of organizations, you will receive a report like this, and this is your responsibility to go knocking these off one at a time, making some changes. Now again, to make the changes, you can't change them in Navisworks. Navisworks just reports. Okay? You have to basically go back to, if you're the structural designer, and it's been decided that you're going to fix or move something, you have to change it in your structural model. If you're the mechanical designer, you go into the mechanical model and change it. Now here's literally the million-dollar question. It's like, okay, I got a piece of ductwork and I got a piece of like structural framing. Like, whose responsibility is it to fix that? Okay, this is where we spend a lot of time arguing, and we have a lot of lawsuits and a lot of conflict over it. Because it could be either of us can go through and fix it. And there's probably, generally in a case like this, it'll be easier to move the ductwork than it is to move the structure. Okay, but it's not necessarily that case, because it could be that, maybe the problem is that in that limited amount of space that you have to go through and create your building, or create all this stuff, there's the floor, here's the ceiling. If the structural designer has put in these nice, gigantic kind of I-beams, they could put very few in there, they're going to span great distances, so it's going to be a very efficient structure, and they've only left you like no room to work with, okay? You may actually have to go back and push on the structural design instead. They may have to do something like that. So there's a lot of ways we can approach this. This morning we were talking about different ways to approach this, and we could do all sorts of things. You could have a piece of duct where you put a big old bend in it. Okay? Not a very efficient thing to do, but every once in a while you go wandering through hallways around here and you'll see things like that, these big old ducts that have all these bends, and they're just trying to get around a beam or something like that. So there's an inefficiency in doing that way, but you may need to do something like that. Other things you can do, it's harder with steel beams. With concrete beams an awful lot, you'll find, people put what I'll call like a block out in the beam. So there's the big old beam kind of hanging around here. We have a duct which wants to intersect with it. So what you actually do is you cut a hole in the beam. And you're actually going to be able to shove the beam right through, or the duct right through that. So sometimes we do that. Another way sometimes we approach this is if you have a system which, instead of having I-beams or solid beams like this, has open web joists, you'll have a top and bottom web, and you'll have some sort of an open lattice between them. And that gives us the ability. We can go through and like run some sort of piece of duct work between the gaps, stuff like that. So there's a number of ways we can do this. It's not necessarily that the beams or the ducts have to move. You know, we could also say that, you know, as opposed to 12 by 12 square ducts, maybe I'm going to have to go with a really low flat duct to fit within that space. Yeah, but there's any number of ways we can tackle this. And really, that's where the artistry, that's where your expertise as designers and coordinators comes in, because the software is really incredibly, it's smart about what it does, but it's also very dumb. All it can do is tell you where the problem is. It's not going to tell you how to fix the problem. So in these meetings where the 10 different designers are together and you're trying to figure out whose responsibility it is to fix, because someone's unhappy because having to go back and revise their design is extra work on their part. No one likes change. No one likes to hear that, but that's the art of what goes on in these BIM coordination meetings. The software is good at identifying the problems, but you know, people and your people skills for negotiating that, that's where it really, that's what ultimately how this gets resolved. Okay, a lot of different ways we can address that. So, it is really good at producing this report. What you do about this report, okay, that's where it gets to be a little bit hard. You know, hopefully on your team it won't be so hard because there's only 2 or 3 of you working together and you'll come up with a strategy and whatever you think is going to work out fairly easily. So what we're asking you to do is take this report, print it out as a PDF. That's just going to make it a little bit easier for anyone to read. So if you have any kind of PDF writer on your software, on your computer, go ahead and just print it out that way. I use something called Primo PDF, which is a nice little freebie PDF writer, but you know, there's a bunch of them. Acrobat, you know, there's a bunch of them that are able to do that sort of stuff. Just go ahead and close that up. Okay, and instead, did Navisworks crash? It might have. Let me open up Navisworks again. Okay, there's my PDF writer. Let me cancel out of that, since I'm not actually concerned with doing it now. We go back into Navisworks. So we can identify the clashes. The next thing that comes up is this whole issue of how do we actually fix the clashes? And let me see if we can sort of address that. I'm going to reopen that session 18. Open that up. Let me go back to Clash Detective. Yeah. Not being very bright, I didn't do a great job of, oops, I opened the wrong thing. Open this up. I don't want to get the Navisworks document, I want to get the one that has the file set in instead. Okay, because I want to be able to go through and get to the original model files. So again, not being very bright, I didn't go through and save these things. Let me go ahead and just kind of save this test this time. I'm going to say structural framing versus ducts. I'll say again, what was I looking at? I think I was looking at the structural framing on level 3, maybe on the roof also. I'm going to learn to stop hitting that control or that command key in just a little while. Okay, so structural framing versus on the MEP side, what was I looking at? We'll say this ducts and duct fittings. Okay, run that test. I'll think about why that is in just a second. 32? Well, we'll leave it at that. I didn't choose all the same things this time. But what I can do is now save that away, and that'll save the test. So if I crash or I reopen it, that test will still be there. Okay. We get to the point then of saying, well, gee, I would like to go through and be able to fix these things. And it's awfully nice that you gave me that printed report. But it sure would be nice if, as I'm looking at this, you could actually take me right back to that Revit model and just show me exactly that piece of ductwork so I can just fix it right on the spot and not have to kind of figure out through the paper where that thing is and get back to it. Okay, and we will do that. And we will do that when you come back. In approximately 5 minutes, we'll talk about switchback and how we use that to do that. And then actually talk about 4D simulation. Okay, so let's go ahead and break for 5. Come on back, and when we do, we'll show you how to make this much, much easier in terms of solving this. So see you soon.